Thank you. It's a pleasure to be here. First, I want to say thank you to the rest of the panel, Christian and Kemp. It's an honor to share a panel with these guys. I've only known them for 1.5 hours, and I feel like we're brothers already. So I think Christian also set up some things for me that was a perfect segue. We didn't plan anything. I've been with Adidas for a long time, almost 20 years now. I'm in innovation now, and innovation for Adidas, innovation has many definitions. What innovation really does is it changes people's lives. And in the previous presentation, you saw a lot of that. It's about experiences. It's about creativity. It's about new things. And that's what I live every day. And for Adidas, particularly in football, innovation is about making athletes better. So very simple. That's the one thing that we carry with us every day. It's our mantra. It's what our founder Adi Dassler did. He worked with professional athletes his entire life. He helped build products to help them win gold medals, to win World Cups, to achieve their impossible. And then you bring that down even to the amateur player. And how can you just hit that free kick or score on a penalty, shoot a free throw, whatever that is to get you to your impossible. Now the process of innovation for us is all about failure. We fail a lot. And you won't find success unless you fail often. The presentation that I'll show you is very specific. It's about this product right here. It's a case study just to show you over years and years how we came to create a smart soccer ball. Now, I'm an innovation director. It's the greatest job in the world. I highly recommend it to everyone. My job every day basically entails doing research, understanding who the consumer is, who the kid is, who the player is, what is the market like. It's also about understanding what the trends are. You saw a lot of trend information prior. And it's also understanding what's the next greatest technology. So I look for that all day. We spend a lot of time in the marketplace just speaking to kids and understanding what they like, how do they want to be better, what don't they like, what are their needs, what are their unmet needs, and really trying to understand that. And from a research perspective, when you think about trends, and Christian talked about it as well, digital is a massive trend. Gen Y, which many of you are in this room, are digital adopters. You've not grown up with mobile phones, but you now know how to use them very well. Gen Z, those that are born 1995 and after, are digital natives. They've grown up with phones in their hands. They understand how to work technology. Now also with these Gen Zs, if I look at just the total football marketplace, it's 270 million players globally. About 226 million of them play unregistered football. So that means they often don't have a coach. They don't have someone to teach them. So we, in our research, found that kids that just want to learn how to kick the ball, what they do is they go to a park with their ball and they just kick it again and again and again and again. And they try to teach themselves. Or they watch someone else do it, or they work with their buddy to try to figure that out. So if we take those two pieces of information together, and this is what I do on a regular basis, is we make connections. If I look at the digital trend and the opportunity to help kids be better, help make better athletes, how could I use a digital solution to help a kid kick a ball? So that's how, one back. Go back, go back, go back. Right there. Oh, one forward. Okay, right there. So that's how this solution started. We wanted to create an intelligent soccer ball that you could use with your smartphone. And we need to think of all these different things, what the user experience was. So how do I experience the ball itself and the phone? So what does that app look like? What's the design look like? The design of the app, is it attractive? Is it difficult to use? What is the design of the ball? How does that look? How does that help me? The engineering, so we use mechanical engineering, electromechanical engineering as well. The software, we wrote all the code that we use in this product as well. Research, so we had to do tons of research in math and applied physics to make sure the algorithms worked. And the product actually showed you how you kicked a ball. Testing, we do tons and tons of testing throughout the entire process with kids all over the world. Manufacturing, this started as a project that we were only going to make 500 or 1,000. How then do you make 5,000, 10,000, 100,000? It's different in terms of manufacturing. And then the culture, it's a totally different product. How do you create a product like this? Something completely new. So if you go to the next slide. So we started in 2005, 4, around there. The 2006 World Cup, we were going to introduce goal line technology in the World Cup. It's a big issue in football in general. And we created this product right here that you see. This little ball inside, that's where all the electronics are housed. And it's suspended inside the ball with 12 cables. And then FIFA said, you know what? We don't need it. And we're like, oh man, come on, Bladder. We got to bring some technology to the game. So we put it on a shelf. And then just a little while later, with this research that we started talking about, we put it together and we said, all right, well, we have the perfect mechanism to create a product that could help someone learn how to kick better. So if we go to the next slide, keep going. One more. Right there. Or you can do the other one. So we started testing the current ball that we had. And after thousands of kicks, that little ball with all those cords looked like that. That doesn't work. And we broke it. So we said, okay, we gotta fix that. That's Kevlar threads. And in the factory, you got to tie each one of those little Kevlar threads by hand. So, okay, that's not going to work either. So we had to go back to the drawing board and figure out a new material. So we actually made the Kevlar like a tire, where we wrapped the Kevlar around a tube and we coated it with rubber, and then we cut little slices and we were able to solve this problem. And we said, great, that's spectacular. How do we get it inside a ball? How do we get it inside the bladder of a ball? So then we had to create a whole new product here that has holes in it so that you could connect each one of those little strings to the actual electronics in the ball itself. So if you go to the next slide, then we would pull that bladder inside out, connect all those things, and voila, we had a ball that worked. But the material that we used originally, when we tested it with players, they were like, I don't like it, it doesn't work, it feels dead. So we had to change the entire material fabrication of the product so that players felt like they were using a ball that they normally use. So we failed again, but we learned something. So we were able to then create this suspended sphere inside the ball. If you go to the next slide. One more slide. There we go. So the next thing we did is we had to build the user experience. We did that right at the beginning. The ball didn't even work, but we had to map out what it was like for someone on their smartphone to go through the process of understanding how to learn how to kick a ball. And we also wanted to make sure that it had the social component. You heard earlier about being connected. Human beings are social creatures. They don't want to be alone. Facebook has 1 billion users. People want to be connected. So how do we connect players and football players? So we allowed you to have a social aspect of it. We allowed you to have competitions as well. You could actually try to copy a ball that Messi kicked or that your friend kicked. You could have challenges to see if you could achieve certain levels. So we built out this entire user experience, and we worked with kids. It was fantastic. We learned a lot. Now, if you go to the next slide, we then built out the how do you kick the ball part. How do you learn how to kick a ball? So we went to kids and we said, okay, what's this look like? Even on the place where you hit it on the ball and on your foot, we were very, very specific. And kids said, I don't care about chipping. And yeah, bending is good, but I want to learn how to kick a knuckleball. So we said, okay. So we went to a lot of our partners that we have relationships with, coaches, other people that just do coaching around the world as well, youth coaching. And we said, okay, we need to learn how to draw out how to kick a knuckleball. And they said, you know what? We were hoping you could tell us how to do that too. So we said, oh, no, that's not good. So we had to map out and do all this research of literally how to figure out the scientific way to kick a knuckleball. And our designer then even plotted on the foot what bone, if you go to the next slide, what bone on the foot you have to hit it with, how you have to approach the ball, if you have to lean one way or the other. He created even the ball with designs on it to show you where to hit that. So we went through this exhaustive process. Again, trial and error. We failed sometimes. We continued to test. We worked with players. It was a fantastic process. But we got to the point where we could finally, particularly the designer was an expert knuckleball kicker after that because he practiced it like 100 times. But we got to the place where we created the perfect experience of kicking a knuckleball. Now, if you go to the next slide, this is what it looks like. So us working with kids in Germany, in the US, in the UK, all over the world. And at that time, you can see these kids right here in particular, they're holding the phone like 1 meter away from the ball. It's because the functionality of it was so poor at that time. The range was very short. We had to actually keep it very close to the phone. But the experience was amazing. They loved it. So we learned what kids liked, how they interacted with the system itself. What were the things we had to change? It was a fantastic process. Now, if you go to the next slide. Then we started to design it out. What would the app look like? So the system can actually tell you when you kick it, the trajectory. It will show you on your phone. It will show you the spin rate. It will tell you the speed. It will even actually show you where on the ball you kicked it and if it was correct or incorrect. So it became a fantastic tool of teaching a kid then how to kick a ball. And again, solving that problem of, hey, I just do it by trial and error. I just go out to the park and do it again and again. If you go to the next slide. So then we also had to figure out, well, how do you charge the thing? And we have this inductive charger. If you have electric toothbrushes, it's the same concept where we have a little cradle and when we started, if you look in the bottom right-hand corner right there, that was a paper cup that was our original charger. We had to solve problems in the beginning. So we went through a ton of different chargers, and in the end, we got to the place where we said we wanted this kid to feel like it was a trophy. And when they had it in their room and it was sitting on a shelf charging, that it looked like something spectacular. So even in the design phase from that, we worked a great deal. And even if I get down really granular, the designer made us a bit crazy in terms of all the iterations that he used just to create the symbol to show you where to put the ball for charging. This is what it's like to work with designers right here. And it took us a while, but we finally agreed on one. Next slide. Now, the sensors, this is very technical right now, but the sensors, in order to figure out how to make this thing work, we tried multiple ones. This right here is a kick. The little waves in the beginning are when you plant your foot. The big ones are when you kick it. And then as it goes along, it's the ball flying through the air. So we tried all different kinds of sensors. We tried pressure sensors, which we realized were garbage. They didn't work in the end because your foot contact. We tried magnetometers, but we realized there's all the stuff that's going on underground, whether it's wires or anything like that. Parking garages interferes with that. And we want kids in the city to use it, so we couldn't use any of those sensors. Finally, we relied on an accelerometer. Very simple, too much detail for you guys to know, but just to show you, like, this is the process that we go to in terms of trial and error and going through this to find the right mechanism to make this thing work. Then we had to test all that math. We did 10,000 kicks. The algorithms within the device itself learn every time you kick a ball. And then when you kick it with the system itself, it then can accurately show you the trajectory. We had to test the math. We had to make sure the physics were correct, that every time someone kicked the ball, they had an accurate shot. And then something funny happened. One of the developers took the ball home, his 5-year-old son, put it on the ground and kicked it, and it rolled along the ground, and it said 82 miles per hour. And we said, uh-oh. we realized that we hadn't calibrated it, or we hadn't worked through the algorithms for rolling yet. And that we couldn't actually calculate that, because the way that the sensors work is the ball has to be a certain level in the air. It has to have a launch angle for it to calculate the trajectory and the speed. So we realized we had to do some quick changes in the end. And the next phases that will roll out will be able to tell you when the ball's on the ground, the speed. It won't be an error anymore. Now it just kicks it out. It won't even register. But that was, again, trial and error. And oftentimes when you're doing innovation, you can't think that you have to get everything perfect. It just, if you try to do that, you'll have the realization that the last 10% of any project takes the longest. And that sometimes you've got to put stuff into the marketplace and you've got to learn. And over time, then you introduce new products that fix that. Everybody that has a mobile phone or downloads the new iOS system knows that. And there are bugs that have to be fixed over time. It's the same thing with any industry. If you go to the next slide. So then we had to do all the videos on the phone and do all the translation. We translated into 12 languages. We used players. This was a local guy, actually. He was on one of the local MLS teams that we used for one of the videos. And he was just like, he had just cracked the first team. And we were like, oh man, we're really worried. Is this guy going to be able to do it? Every single kick, first time, boom. Corner, boom. Bending, boom. Knuckleball, it was amazing. So we were able to get great video within the system itself. And when a kid goes into the phone, he can actually take a tutorial first to show him how to kick a ball. Or if they want to take a pro challenge, they actually see these shots, this video, and then they have to copy it. And then the system then shows you how accurate you were. If you go to the next slide. Now, this is what you'd think manufacturing of a smart ball would look like. Very automized, very technical. And if you go to the next slide, this is actually what it looks like. It's a bunch of guys standing around putting stuff together with their hands. So here, we take the bladders and we actually dunk them in buckets of water to see if there are any air bubbles. So very high-tech stuff. Sometimes the best solutions are the simplest solutions, I have to say, and the cheapest solutions. If you go back one, I just want to say one more thing, because this was such a new product. We also had to develop all the testing equipment. So if a ball came off the manufacturing line, how do I test if it works? How do I test if it's durable? So we have all these test equipment that we had to build. We had to build all the testing standards. We had to teach the factory how to conduct all the tests, and then put in a whole quality control system in the end. So it was very, very new for us. And then we also have to test the ball just like any other football. And FIFA has very exacting standards for weight, for circumference, for rebound. One of those tests is that you fire a ball from a distance of 8 feet against a steel plate, 60 miles per hour, 3,500 times. So we had to test that with all these electronics in there, and we were like, oh God, is this gonna work? And because the electronics are suspended within the ball with those Kevlar cords, there's no vibration, there's no damage to that at all. So we were able to actually pass all those tests. We've actually exceeded those tests wildly. So every product that we do, we've got a very exacting standard that we've got to hit. If you go to the next slide. Now, at the end of the day, this was the product. We launched it in June. It's an expensive product. It's $299, but it's the first of its kind in terms of the capabilities that it has. And it solves a problem in the marketplace. And originally, as I said, it was only supposed to be 500 or 1,000, and it ended up being 85,000. So it's been good. It's been a good pilot program, and we'll see how that grows over time. And we'll see how we can connect this product to a larger digital ecosystem. So how do you connect it to other digital products that are out there in the marketplace from a football perspective? Now, when you use it, as I said, when you learn how to kick and you test this product out, it gives you your speed, your spin, your trajectory, but then you can share all that. Now, the most important piece, as I said before, is about that social competition. You want to be able to tell your friend, you're better than him. I kick the ball harder than you. I can hit that shot better than you. This allows you to do that. Now, you can share your results on Twitter or Facebook in the end. So it's a a teaching app, it's a coaching mechanism, but it also is a social platform to allow kids to then show off their skills. So that's my story, and I want to say thank you.